Welcome to Study Loop.
19.61. So we have a milliammeter that reads 35 milliamps at full scale. It consists of a 0.2 ohm resistor in parallel with a 33 ohm galvanometer. And so we want to change the ammeter to a voltmeter with a 25 volt full scale reading. And we can't take the ammeter apart. And we want to figure out what the sensitivity of this voltmeter is as well. So first off, let's think about what this circuit will look like. And basically the only thing we can do is either put an external resistor in series or in parallel with the connections to our milliammeter. We need to put it in series so that you want to have as much resistance as possible for a voltmeter. And the idea here is that we pick this resistor R. So this is the shunt resistor, this is the resistance of the galvanometer. The idea here is that we want to pick the value of R here so that the full scale voltage that's applied across our terminals out here, when that voltage is 25 volts, we want the current through here to be 35 milliamps. So in other words, we want the full scale voltage, 25 volts, to be equal to the full scale current, which is 35 milliamps, times an equivalent resistance. So the equivalent resistance is going to be our added resistor here in series with the parallel combination of our shunt resistor and our galvanometer's internal resistance. So this will be R plus the shunt resistor times the galvanometer resistance divided by the sum of those. And so solving this for R, we have our full scale voltage divided by our full scale current. And then from this we subtract the equivalent resistance of our ammeter. And so then we know everything over here, and evaluating this gives us 714 ohms. And then the sensitivity is going to be our 714 ohm resistance divided by the full scale reading of 25 volts. So 714 ohms divided by 25 volts. And this is 29 ohms per volt.